Let's take a look at getting ready 4.3. Alright, so these first problems are dealing with recognizing the greater rate of change when comparing two linear or two exponential functions. So remember, linear straight lines, exponentials are not. Now, some of these are probably a little difficult to tell what's going on, but if we look at this first one, you've got one like this, and then you have one like this. Okay, so you basically want to know which one is growing faster. When we think about a greater rate of change, we're basically thinking about how quicker it goes up. Okay, that's kind of the way to think about it. So if we're looking at this one, which one of these is going up higher at a quicker rate? Well, I think it should be pretty apparent that it's the purple one, which I believe they called f of x. Right there, you got f of x and g of x. So the function f of x is growing faster. If you look at number 2, I only see one graph, so I'm not sure what's going on with this one. I don't know if it may not have printed out correctly. Yeah, it looks like we just have the one right there, but I don't see anything else going on, so probably say that one. And you can circle them too, you don't have to write them in. So if we look at number 3, we've got this graph right here, and you've got this graph right here. Well, which one's growing faster? The orange one. So you'd circle that one. Okay. Now, look at 5 and 6. These ones are dealing with the exponentials. So which one of these is growing quicker? Well, it's the one that's going to be jumping up at a faster rate. As you look this way, which one is going quicker? Well, it's that f of x one. For number 6, it's that p of x one. That's the one that's growing quicker. So that's kind of all you really had to do on those ones. Okay, now let's take a look at, you've got two problems like this. So basically what they want you to do is, come up with, you're given one of the pieces, you need to come up with the other ones. Okay, so a great place to start is going to be the table. So it says you and your friends go to the state fair. It costs $5 to get into the fair and $3 each time you go on a ride. So they've got the rides here for the the input, the x, and the cost for the output. So if we don't go on any rides but we go to the fair, how much would it cost? Well, it costs $5. That's what they told us. Okay, and it's $3 each time you go on a ride. So if I go on one ride, well, I paid the $5 to get in plus the $3 to ride the ride. If I went on 2, well, we'd have to add $3 more to it, right? If I went on 3, we'd add $3 more to it. And you could keep going, but that's enough. So then we graph it. So let's make this my x and y. So x and y axes, and then graph it. 0, 5. Be right there. 1, 8. And if I'm looking at my graph, I may want to actually do my axes different, huh? Because if I'm thinking according to the context of my problem, oh, did I miss the axes? I think I did. They had it like this. Okay, so just the positive sense will be positive. So 0, 5, 1, 8, so up 3 more, 2, 11, 3, 14, oops, wrong one, and so on. And then you could draw your graph. Okay, now something we would have to think about is, can I ride more than one ride? So if we drew a line, wouldn't that technically make this a continuous? Which this isn't continuous because I can't ride 1.5 rides. So we should actually get rid of that and just have our dots. like that. Okay, now the equation. Remember, when we're doing an equation, we can start it out easy. Now we could do a recursive equation, and we could write something like, f of n, our next term, is equal to the previous term plus 3, and we started out with 0 and 5. Okay, you could do that. However, I would prefer that we try to write the explicit equation. And remember, for the explicit equation, we think like this. Well, the function is equal to what? Well, we started at 5, right? And what did we do to that 5? We added 3 to it. How many times are we adding 3? Well, that depends on how many rides we go on. So, since our variable is n, if we went on n rides, we'd times 3 by n. And that would be our equation. Okay, there we go on that one. Now, on the go section, it wants us to write a recursive and an explicit equation. Okay. So, Marissa has saved $1,000 in a jar. She plans to withdraw half of what's remaining in the jar at the end of each month. Okay, so if you needed to draw a picture, you could have a jar in here, and you could have lots of money. Okay, but basically, she's going to start out with it being full of money, and then she's going to withdraw half of it for each month. So half of what remains, half of what remains. That's kind of what you're thinking here. So, and she had $1,000 to begin with. So we started out with 1,000, then at the end of the month we'd go down to 500. At the end of the month, 250. Okay? So, make it into a table. A table is always easy to deal with. So we've got the month and then the money. So she started out with 1,000. Then after the first month went down 500. Second month went down to 250. So what is happening here? Now notice they're telling us for a geometric sequence. Remember, geometric is like multiplying or dividing. The thing is, we can't really divide when we're making an equation, so we have to actually think multiplication. How? It's pretty obvious that we're cutting it in half, we're dividing by 2. Well, how do we make that into a fraction? And multiplying, dividing by 2 is like timesing by a half. That's what we really need to be thinking here. Okay? So for our recursive, to get our next amount, we take the previous amount, and what did we do? We times it by a half. You could write divide by 2 there. Where did we start? Well, we started with 1,000. Okay, and that's our recursive. Now for the explicit, we started out the same way. We say, to figure out our answer, it is equal to, where did we start? Look at when we have 0, and it's 1,000, so we started at 1,000. What did we do to that 1,000? Well, we timesed it by a half. How many times are we timesing it by a half? We don't know, because we'd keep going. So it's like we're saying in n months. So we'd go 1/2 to the n power, like that. And that's what your explicit would look like. Okay, let's take a look at 2 more. So now we've got one that's already got a table for us. So we've got recursive and we've got explicit. So we're going from 10 to 100 to 1,000 to 10,000, so we're timesing by 10 each time. Now remember, we've got time of days. We need to know where we started. We need to know the 0. So we have to go backwards. So what number times 10 would give us 10? Well, it's 1. In other words, 10 divided by 10 would take us back to 1. So our recursive, we'd say, to get our next answer, we take our previous answer and we times it by 10. And where did we start? We started at 1. For our explicit, we'd say, to find our next term, well, to find any term, what we do is we start at 1, and then we're timesing it by 10. How many times? Well, it depends on which day we're talking about, so we call it n, and we raise it to the n power because we're dealing with multiplication. Okay, or you could have written it y equals 1 times 10 to the x. That works as well. Okay, now let's take a look at number 13. So we've got our recursive and our explicit. So what's going on here? We're going from 1024 to 256 to 64 to 16. So we're getting smaller, so it's kind of like we're times them by a fraction. In other words, dividing. So I believe it's 4 that we divide by. 1024 divided by 4, let's see. We're going 2, 8, 22, 5, 26, yep, 256. So from here to here, we're either dividing by 2 or 4, dividing by 4, or we should think multiplying by 1/4. 256 to 64 is the same, to 16 is the same. So for our recursive, we say to get our next answer, we take the previous answer, we times it by 1/4. And where did we start? Our first term was, running out of space, our first term was 1024. Okay? So, for our explicit, we're going to have to go backwards one to find where our 0 term would be. Okay? Because it's a sequence, it's kind of a little bit different than we're kind of thinking like we are a table. You know, if I were to erase this, and if I could go like, oh, let me erase this part too. And if I were to make this a table, this would be 1, 2, 3, 4. So to get back to 0, we're going to have to work backwards, so we'd have to times that by 4 to find out what number we started with. So it'd be 4096. So for our explicit, we say to get our answer, or any answer, we started out at 4096, and what did we do? Well, we timesed it by 1/4. How many times? As many times as we want, or in other words, our variable. Okay? And there we go. There's some practice with some of those geometric, making recursive and explicit.